The Formula One paddock is in uproar after detailed specifications of Ferrari's 2026 front wing leaked, prompting multiple rival teams to formally demand penalties from the FIA. Sources suggest this could mark one of the most contentious regulatory battles in recent F1 history. The leaked wing reportedly features a sophisticated hydraulic actuation system, enabling real-time adjustments to downforce and drag. Rivals fear this innovation could provide Ferrari a decisive advantage in both corners and straight-line speed, potentially altering the competitive order before the season even begins. Insiders indicate Ferrari has tested over 50 different wing configurations under the internal Project 678 program, including high downforce and low drag modes that could redefine the use of active aerodynamics in 2026. Yet how fully optimized these systems are remains unclear, and later in the video, we'll break down exactly why the rivals are so alarmed, analyze the leaked aerodynamic data, and explore the potential penalties and FIA decisions that could reshape the grid. But the full consequences have yet to unfold. What you'll see next may change the narrative of the entire season. The Formula One paddock has been thrown into a state of intense scrutiny following the leak of Ferrari's 2026 front wing specifications. Rival teams, including Mercedes, Red Bull, and McLaren, have formally demanded that the FIA investigate and impose penalties, claiming that Ferrari's new design could offer an unfair aerodynamic advantage. Insider sources suggest that the wing incorporates a sophisticated hydraulic actuation system capable of adjusting the angle of attack dynamically during a lap. This innovation has the potential to optimize downforce and drag in real time, giving Ferrari a performance edge in corners, straights, and tire management that rivals may find difficult to counteract. At the core of the controversy is the hydraulic system's ability to respond to changes in airflow over the front tires and the car's underbody, effectively fine-tuning aerodynamic efficiency on the fly. Rival engineers are concerned that this could blur the line between legal innovation and illegal movable aerodynamic devices, which are restricted under FIA regulations. Although Ferrari has publicly asserted that the design complies fully with the rules, competitors are carefully studying the leaked data, seeking to determine whether this dynamic capability could translate into measurable lap time gains and strategic advantages during the early part of the season. The FIA's handling of the situation has further heightened tensions. While protests have been officially acknowledged, no immediate ruling or clarification has been issued, leaving rival teams in regulatory limbo. Historically, delays in such rulings tend to favor teams pushing the boundaries of the rules, as competitors hesitate to pursue aggressive aerodynamic innovations without clarity. This uncertainty has forced rivals to adopt defensive approaches in wind tunnel testing, simulations, and development programs, recalibrating their strategies to anticipate Ferrari's potential advantage while minimizing the risk of regulatory sanctions. Ferrari's Project 678 is reportedly central to this innovation. Sources indicate that the team tested over 50 different wing and nose configurations, optimizing airflow and downforce for various track conditions. The leaked information also suggests that Ferrari has implemented multiple operational modes, such as high downforce and low drag setups, enabling the car to adapt dynamically across circuits. This adaptability has caused concern in rival garages, where engineers are urgently evaluating how to counteract the potential gains without overstepping technical or regulatory limits. The leaked data has triggered a significant recalibration of pre-season strategies across the grid. Teams are revisiting aerodynamic maps, suspension setups, and tire allocation strategies in light of the potential advantage Ferrari may possess. Every simulation, CFD study, and track test is being scrutinized for insights into how the dynamic wing system operates. Even minor miscalculations could result in lap time deficits, emphasizing the pre-season's importance as a period of both preparation and defensive strategizing against Ferrari's potential hidden edge. Psychological pressure has also intensified. Drivers are aware that Ferrari may have a concealed advantage that could affect cornering behavior, straight-line speed, and overall race performance. This knowledge influences qualifying aggression, overtaking decisions, and race pacing. The mental strain of competing against a technically superior or unpredictably adaptive system adds a critical layer to pre-season preparation, demonstrating that high-level Formula One competition is not only about mechanical excellence, but also about strategic foresight and psychological resilience. Finally, the implications of this controversy extend well beyond early-season competitive balance. The FIA's ultimate decision on the legality of Ferrari's front wing will set precedent for movable aerodynamic devices and influence car development philosophies for all teams. Budget allocations, technical priorities, and strategic planning for 2026 may all be reshaped depending on the ruling. The leaked information has transformed pre-season preparation into a high-stakes arena dominated by technical innovation, strategic anticipation, and regulatory uncertainty, ensuring that tension and drama dominate the paddock long before the first race of the season. The leaked specifications of Ferrari's 2026 front wing immediately sent shockwaves through the Formula One paddock. According to insiders, the hydraulic actuation system allows the wing to dynamically adjust its angle of attack mid-lap, altering downforce and drag in real time. While Ferrari insists the system is fully compliant with FIA regulations, rival teams such as Mercedes, Red Bull, and McLaren are conducting extensive analyses to determine the potential on-track impact. Even a minor aerodynamic advantage can translate into tenths of a second per lap, giving Ferrari a critical edge in qualifying and races, forcing competitors to reconsider their pre-season plans under pressure. The controversy stems from a hydraulic system's ability to respond to airflow over the front tires and underbody, allowing Ferrari to continuously optimize aerodynamic performance. Rival engineers are concerned that this capability could exploit a gray area within the FIA regulations regarding movable aerodynamic devices. Teams are now attempting to predict the system's effect across different circuit layouts, evaluating how it may influence cornering speed, tire degradation, and straight-line acceleration. This uncertainty has introduced a layer of strategic complexity into pre-season preparations, as teams must develop contingency plans without fully understanding Ferrari's hidden advantage. Leaked data also reveals that Ferrari has tested more than 50 configurations of the wing and nose, combining computational fluid dynamics with wind tunnel testing to maximize efficiency. Reports indicate the team developed multiple operational modes for different track conditions, such as high downforce corners and low drag straights. Rival teams are racing against time to simulate these configurations and determine how best to respond, either by adapting their aerodynamic packages or by preparing defensive strategies to minimize potential deficits. The dual-mode adaptability could allow Ferrari to maintain optimal performance across a wider range of conditions than any competitor. The FIA's delayed response has amplified tension throughout the paddock. While protests have been formally lodged, no ruling or guidance has been provided, leaving teams in regulatory limbo. Historically, such delays can advantage the team operating at the edge of compliance, as rivals hesitate to push aggressive aerodynamic innovations without clarity. This regulatory uncertainty forces competitors to carefully weigh the benefits of technical innovation against the potential risk of penalties, adding a critical layer of strategic and operational stress to pre-season planning. The psychological impact on drivers cannot be underestimated. Knowledge that Ferrari may have a hidden aerodynamic advantage alters qualifying strategies, race pacing, and overtaking decisions. Drivers must mentally anticipate how corners and straights might behave differently due to the adaptive system, introducing additional stress into pre-season testing and preparation. The pressure of competing against an opponent whose advantage is partially concealed demonstrates that modern Formula One requires not only technical skill, but also psychological resilience and strategic foresight. Strategically, teams are now reassessing their pre-season programs to counteract the potential advantage revealed by the leak. Engineers are recalibrating aerodynamic maps, adjusting suspension setups, and reviewing tire allocation strategies. Wind tunnel tests and track simulations are scrutinized for subtle insights into Ferrari's system, while even minor miscalculations in predicting its behavior could result in measurable lap time losses. The leak has shifted pre-season priorities from purely developmental optimization to defensive preparation, forcing teams to consider Ferrari's potential moves in every technical decision. Finally, the broader ramifications of the leaked front-wing data extend beyond immediate performance concerns. The FIA's eventual ruling on the legality of Ferrari's design could set a precedent for movable aerodynamic devices, influencing development philosophy across all teams. Budget allocation, strategic planning, and long-term car development may all be reshaped depending on the outcome. The leaked data has transformed pre-season into a high-stakes arena dominated by technical innovation, regulatory ambiguity, and strategic anticipation, ensuring that tension, speculation, and drama dominate well before the first race of the 2026 season. The The critical twist emerging from the leaked Ferrari 2026 front wing data is that it has the potential to redefine the balance of power for the entire season. Rival teams are now forced to prepare as if Ferrari holds a hidden aerodynamic advantage capable of delivering lap time gains across a wide variety of track conditions. Engineers and strategists must operate under the uncertainty of unverified performance data, recalibrating simulations, wind tunnel testing, and pre-season development programs to anticipate Ferrari's potential advantage. The psychological impact of preparing for a competitor with a possibly concealed technical edge has introduced unprecedented tension across the paddock, making every decision, from component selection to strategy sessions, weighted with higher stakes. At the heart of this twist is the hydraulic actuation system that allows Ferrari's front wing to adjust its angle of attack dynamically. Although officially compliant with FIA regulations, the system could consistently provide performance advantages that rivals cannot easily replicate. Teams are now modeling worst-case scenarios to predict how the wing behaves in different corners, straights, and under varying airflow conditions. The uncertainty surrounding its capabilities has forced rival teams to rethink not just aerodynamics, but also suspension setups, tire strategies, and energy deployment plans, turning pre-season preparation into a complex balancing act between innovation and defensive engineering. The FIA's delayed response has further amplified the stakes. Despite the protests filed by multiple teams, no ruling has been issued, leaving competitors in a state of regulatory limbo. Historically, teams that operate at the edge of compliance tend to benefit from such ambiguity, while rivals hesitate to implement aggressive aerodynamic designs without clarity. This situation creates a high-pressure environment where every wind tunnel test, CFD simulation, and track run must be evaluated not only for performance, but also for compliance risk, blending technical and strategic considerations in ways rarely seen before. From a tactical perspective, the leaked front-wing data has forced rival teams to adjust pre-season priorities. Engineers are recalibrating aerodynamic packages, testing alternative wing configurations, and reassessing suspension geometries to anticipate Ferrari's performance envelope. Even minor miscalculations in understanding how the hydraulic system functions could result in significant lap time deficits across multiple circuits. The leak has effectively shifted pre-season focus from incremental optimization to defensive preparation, requiring competitors to anticipate Ferrari's moves while refining their own setups under immense time pressure. Psychologically, drivers are operating under added stress. Awareness that Ferrari may have a hidden performance edge affects qualifying strategy, race pacing, and overtaking decisions. They must mentally prepare for corners and straights that might behave differently than expected due to the adaptive nature of Ferrari's wing. This mental challenge underscores how modern Formula One demands not only mechanical performance and strategy, but also acute psychological resilience, as the perception of an advantage can be as influential as the advantage itself. The regulatory and political dimension of the twist is equally significant. The FIA's ultimate ruling on the legality of Ferrari's front wing will likely set a precedent for movable aerodynamic devices in 2026 and beyond. Rival teams are acutely aware that the decision could reshape development strategies, technical priorities, and budget allocations across the grid. The controversy demonstrates the complex interaction between innovation, strategic foresight, and governance, where technical ingenuity must be balanced with regulatory navigation to secure competitive advantage. Finally, the broader impact of this twist extends well beyond lap time considerations. The 2026 championship may be influenced as much by strategic intelligence, regulatory interpretation, and psychological resilience as by raw aerodynamic performance. Ferrari's potential hidden advantage, combined with the FIA's delayed ruling, has transformed the paddock into a high-stakes arena where anticipation, adaptive planning, and preemptive strategy dominate. The leaked front-wing data ensures that pre-season activities, simulations, and testing carry amplified consequences, establishing a foundation for a season in which preparation and insight may dictate ultimate competitive outcomes.